Okay. And you can tell the person's hair color and eye color are listed so that you can have black, blonde, or red hair. I know it's weird because most people, I don't know, people I ask, say, do I have brown hair? And I think I do, but well, I used to have more hair. But in the, and they would say, no, you have brown hair. So, but we're just going to say brown and black hair are the same, I guess. And then here's the eye colors. And so if you had like hazel, you might go in as green. If you had, you know, or brown or something. But anyway, we categorize them and then we collect all the data and we organize it in a table. So we can ask the question here. How many students have blonde hair and blue eyes? That's not too hard. You just take a look at blonde, blue eyes, and you see it's 4. How many students have red hair? Red hair, well, not 1 or 3, but total 4 people have red hair. And that's how we read these columns. If you ask for one category, you look in the total. If you're looking for a mixed category, you look for where they intersect. Yeah, let's construct one for ourselves for the data above. All right. Frequency is a way to say how many times an event occurs. I'm not sure I need to write this down. I just need to explain it, I think. It's just a percent, okay? And so it's a ratio of how many things that you're interested in over all the other occurrences. So let's take a look at, and I feel like I need to zoom out so I can get both tables in. Okay, so I'll do this first column. The number of black-haired folks who have blue eyes is 3, but there's a total of 20 people. 20 people, so 3 out of 20 is the frequency with which people have black hair and blue eyes. And if we divide those, we get 0.15 or 15%. Okay, so I don't know if you can fit all that information in there. Let's do this for blonde hair and, well, any questions? Blonde hair, okay, and blue eyes. Well, there's four people there out of the 20. And when you divide those in your calculator, you get 0.2 and you get 20%. Now, this looks like something you could just watch. Oh, Annabella's back. But I'd like you to be able to do the next rows. I'm just going to do the first row for you. Red hair, this is the most rare of all hair colors. It's 1 out of 20 with blue eyes, and that's 0.05, which is 5%. Now the total people with blue eye color is 8 out of 20, or 0.4, which is equal to 40%. All right, what I'd like you to do is take a minute to fill in these tables with the information. Hey, Ethan. So we're on lesson 5, and we're just doing frequency tables of hair color and eye color. And we have this data here, and we're making percentages out of them. So we just look at how many people with brown hair and brown eyes. It's 5 out of 20, which is also known as 25%. Okay, so fill that table in, and we'll meet back up. Give me a signal maybe in chat or something when you're done. Annabella, no problem at all. Hey, Annabella, what color eyes do you have, if you don't mind me asking? I need to add it toward this. And Ethan, what color of eyes do you have? Oh, wait, did you already tell me? Yeah, Annabelle, you already told me you have hazel eyes. Ethan, what color of eyes do you have? Ethan. All right. Ethan just said hi, but Ethan's not there. All right, so we'll check that out. When you're done, take a look at your frequencies. Does anyone have any questions on that? Okay, let's move on. On the page, here is a connection between eye color and hair color. And this is called a conditional relative frequency, which means it's a frequency, but it's conditional on some other second variable. So what does it mean if they say, what is the, I'm trying to get both things in there. There we go. The conditional of having green eyes if you have red hair. That's equivalent of asking what the percent of people with red hair have green eyes. So it's saying like, okay, so I'm first on to say I need to look only in one of these categories. That's the condition. And then a frequency is, of course, the number within that category. So let's break this down. What is the condition of if you have having green eyes if you have red hair? So the question is, if you have red hair, well, how many people have red hair? 4 people have red hair. So it's out of 4 people. And how many of those people have green eyes? Green, 3 people of the red hair category. So when they say if, whatever follows if is the condition you have to look under. So if they have red hair, the number of people they have that is, so this is a conditional frequency. It doesn't match what we did before, right? That's 75%. 75% of the total people don't have green eyes and red hair, but 75% of redheaded people have green eyes. And I'm not sure if that's true in general, but I think it is. Okay, what is the conditional frequency of having green eyes if you have black hair? Well, that's really an interesting combination. So of having green eyes if you have black hair. So I need to look under the black hair column. Okay, and only 1 out of the total 9 people who have black hair have that. And when I do the math there, it turns out to be 0.11 repeating, which is equal to 11%. About. Does it appear that having green eyes has a dependency or at least an association with having red hair? Explain. Yes, it seems like it. It seems like they go together. Because that a person jumps, if you have red hair, it's really different to have green eyes. In general population, only like 25% of people have green eyes. You know what I mean? Well, let's take a look at the data. Only 25% of the general population. So if it wasn't associated, so I'll write that down, 25% of the general population have green eyes, but 75% of redheads have it. So it seems like something's going on. Oh, I didn't write that down. Does that make sense? Okay, good. Okay, good. Like no one said anything, but I'm just assuming it makes sense. Is it more likely that a person with black hair has blue eyes or that a person with blonde hair has brown eyes? All right, we'll take a look at that. There are 9 people with black hair, and 3 of them have blue eyes. So we're going to take 3 out of those 9 people, and the relative frequency is 33%. Now, there are 7 people with blonde hair, and 2 of them have brown eyes. So 2 out of 7 is equal to 29%. So it is more common for people to have black hair with blue eyes okay. I wonder if I can make this larger. Yeah. All right. This one's a tricky one. A survey of 52 graduating seniors conducted to determine, let me zoom out a little, where they were going to college based on the data. What is the more likely that someone's going to college is female, or that someone who is female is going to college? And that seems like the same question, doesn't it? But it's actually asking different things. So the first question is like, we're going to look at, oh, all the females, just looking at the females, what percent are going to college? And then we're going to look at all the college people and see how many females there are. Okay, so they're asking two different things. They're saying, of all the females, how many percent are going to college? Or of all the college people, how many of them are females? So let's take a look at what it is. So we take a look at the females. For all the females, there's 22 females. And of those 22 females, 13 are going to college. And that's 45%. I did the math for you. Okay. And for the college kids going to college, there's 29 kids. And of those, 13 are females. And that's 59%. So 59% of people going to college are females. Isn't that interesting? I think that's really interesting. Okay, so your homework on this one is just to do 1 through 5 on this page. Okay, first page. All right, that's good. Now, it's always good to do all of it if you're looking to do even better, more work and get ready for the regions. But I only have, I'm doing double notes, so I'm not going to make everyone do both sides of the homework. But it is a good idea to start doing more work to get ready for the test. All right, let's go ahead and begin with the next lesson. Lesson 6. It's called bivariate data analysis. Bivariate seems like a big word. Bi, means two. Variate means variables. That means sometimes two things have variables. For example, you could have a low temperature and a high temperature, and they could vary day to day. Every day has a different temperature. Construct a scatter plot of this bivariate data set on the grid below. All right, the nice thing is they already have all of the axes labeled. We just have to plot them here. So let's take a look at this. This is really the point 26, 49 on the grid. So I'm going to go to 26. Let's look how they're numbered first. Looks like it goes 22, 24, 26, 28, 30. So 24, 22, 24, 26, just to help me get it arranged the first one correct. And then I have to go all the way up to the high temperature of 49, which is really close to 50. So I'm just going to go a little bit underneath 50 and put a dot there for my first point. And I think you see what I'm doing. I'm going to go ahead and put all the dots. Please do this on your own. This is a very good independent activity. So go ahead and put the dots. I will obviously do my own dots, and then we'll meet up in just a little bit. Okay. All right, I have all my data points down. You might still be working, which is totally fine. And I need a ruler. I'll be right back with a ruler. All right, let's look at the questions. We constructed a scatter plot on the grid below, check. Draw a line of best fit through this data. You might have seen this word before. A line of best fit should be a line that goes through as close to touching as many dots as can, but it has to be solid, all right? So that's something important. I'm going to find a line that goes through as many as I can. Without minimizing the distance between all of the dots. So that's my line of best fit. You could have a different one and I would not be offended. Looks like it crosses here. Try to find 2 points where it crosses once you draw your line of best fit. You don't want to force it, but you do want to find 2 points that gets really close to. I think it's pretty close to being here. All right, so there's 2 points that it intersects pretty closely. Okay, draw a line of best fit, check. Calculate the slope of this line. I'm going to see how much up and over it goes. All right, you could do it from anywhere, but I'm going to find 2 points. I should use my black pen, 2 points that it goes through. Mine is 3256. And my other point is 4066. You can use my points or you can find your own. So I found 2 points and I'm going to calculate the slope, which is the change of y over the change of x. And the way you calculate that is you do y2 minus y1 over x2 minus x1. The second y minus the first y, 66 minus 56. And the second x, 40 minus the first x, 32. And when you subtract those, you get 10 divided by 8. And when you simplify that, you get a slope of 1.25. Right? So the slope is 1.25. Check. Use your line of best fit to estimate the high temperature for a day in April, given that the low temperature was 42 degrees. All right, so for a low temperature of 42 degrees, we're going to look over here, look all the way up. And what I see is it's just below 68 degrees, but it's pretty darn close. So I'm going to say 68 degrees. Illustrate your answer with a graph. This is at 42 degrees. 42 degree low is a 68 degree high. All right. Would you characterize the relationship a positive correlation or a negative correlation? This is from, I believe, 8th grade as well, but we'll have to review it. A positive correlation of data move upwards as one goes up, the other goes up. A negative correlation means they go down. All right. So those are correlations. In this case, it's called a positive correlation because as low temperature goes up, high temperature goes up. All right. Any questions on the first page? I don't think it's that bad. All right, let's go ahead and turn the page. Each of the following scenarios, two variables are given that would be plotted would have a strong correlation. That means it would nearly form a line. Determine if there exists a causal, that's a new word, relationship between the two variables. This means, it's a fancy word, and it's funny because it means causes something. So just because two things go up together, it doesn't necessarily mean one causes the other. So let's take a look at it. Does the high temperatures of New York City and the number of bottled waters sold, is that causal? Yeah, definitely. As the temperature goes up, more people buy water, right? So that's, the answer is yes, definitely causal, because it's hotter. People get thirstier. How about a person's height and a person's shoe size? Does one cause the other? Well, no is the answer. No, your height isn't causing your feet to grow. Your body size does. And they're both related to a third variable called body size, but it's not related to each other. So the height and a person's shoe size, they do go up together, which means, oh yeah, as shoe size and height increases, but just because they get correlated doesn't mean they cause each other. Okay, no, your height doesn't change your shoe size. They just go up at the same time. Like they're not related to each other. Like going up in temperature causes people to be thirsty. Getting taller doesn't cause your feet to grow. A third variable is happening there. So no, height isn't causal. A person's weight loss and the number of hours they spend in the gym, is that causal? Yeah, so I mean, if this is the number of hours you spend in the gym and this is your weight, you know, the more hours you spend, the less you weigh. Now it's not true for everybody. Some people go to the gym to get all big, but most people just go there to lose weight and be healthy. So I would say that no. Oh, sorry. Is it causal? Yes, it's definitely causal, because as you go to the gym, you'll lose more weight. The years of education and the salary you make. More so in the past, but it's still true now that the more college and education you get, the more options you have, which usually people choose options that pay them more. So yes, this is causal. One causes the other. I hope that makes sense. There's other cool ones, but here's an interesting one. It might be weird. The table below shows the number of firefighters required to fight a given fire and the dollar damage done to the house by the fire. So if you have two firefighters come, there's $2,000 or whatever that much damage. When there's three firefighters and so forth. So you see how they're both going up together? As one increases, the other one increases. So that means they're related. That means there's a strong relationship. It doesn't necessarily mean there's a causal relationship. Are they positively or negatively correlated? Well, remember, positive things go up together and negative things cause each other to move in opposite directions. This is definitely positively correlated. Does the number of firefighters cause the damage done to the house, though? Oh my goodness, mostly the answer is no. Okay, so no. There is what we call a lurking, and it's probably the most important ignored thing I can teach you, variable. That's the way people lie to people in media and on TV and radio and podcasts and YouTube, is they don't mention there's a lurking variable. They don't mention because they don't know, or they're trying to deceive you. They do this to sell things. They do this to persuade you for politics or whatever, but they don't mention the lurking variable between two things that maybe go up with each other, like the number of firefighters and how much damage is done to a house, but it doesn't mean they're correlated or they're not causal. So some people say, well, the way we reduce the damage by fire is reducing the number of firefighters. No, that is not the answer. Just because there's more firefighters at a house that's really damaged just means that there was a big fire and they needed to have a lot of firefighters to fight it. So there's no causal relationship. A lurking variable means that the fire is the thing that's destroying the damage. Okay, so the fire is the lurking variable. All right, that concludes our 2 days of lesson notes. Do you guys have any questions? And the homework for tonight is just the first page too, for minimum, okay? Extra credit if you do both. I'll do whatever I can to improve your grade if you can do both sides of the homework, because that would really help. But I don't want to assign both sides because there's just a lot. I don't want to double your work too much. Okay, if there's no questions, you can check out a Zoom. That concludes the lesson, but I'll be glad to take questions or help you start the homework or whatever you like. All right. Oh, and I did finish comments in your grades, and I can share them with you on Zoom, but you should be all updated. Remember, if you do extra work and you submit it on Google Classroom, I can't see it unless you email me, so make sure you email me that you're doing it. All right. Well, have a good day if you have no questions. Otherwise, I'll be here. Thank you, Annabella. You too.